Good morning, students. I hope everybody is fine and in the pink of their health in this pandemic situation. So I welcome you all to the final year. First of all, congratulations to everyone on entering the final year, and I hope this year will be much better, and you all will experience this new online learning which we have been doing. So congratulations for that, and let us start with the new subject, that is theory of reinforced concrete structures. So this is the new syllabus which has been introduced, and this subject is a combination of two subjects. Actually, in the previous semesters you had two different subjects, that is WSM and LSM. So this is a combination of both the methods, that is working stress method and limit state method. So in this, I think many of the students who are from diploma, they already know what is the working stress method and limit state method. So for other students, this is the new subject. So we will go in detail. So as the name suggests, theory of reinforced concrete structures. So basically it's a design subject. So far we have seen, you have done the analysis part, then this is the introduction of the design. So in the analysis, you have done structural analysis 1, structural analysis 2, and now this is the introduction of RCC. I think you have been introduced to steel design. So this is also similar. The only thing is we are going to design RCC structures. So I hope that is clear to everyone. So let us move ahead with the presentation. So this is the new subject, that is the scheme of the subject for you. The subject code is CEC 702 and the subject name is Theory of Reinforced Concrete Structures. So in this you have the evaluation scheme. I'll just come to the evaluation scheme, that is important. So you have term test which is of 20 marks, term test 1 and term test 2, and the average will be considered, and then the theory exam is of 80 marks and the duration of the exam is 3 hours. So please make a note of it. So it's a mistake over there. So the duration of the end exam is 3 hours, and then you have term work of 25 marks and then oral of 25 marks. So I hope the evaluation scheme is clear to everyone. So now we'll just go to the next slide. So now let us see what are the objectives of the subject. So remember one thing, whenever we start with any new subject, we must always ask this question, why are we studying this subject? Okay, so this is the answer for that. So what are the objectives of this subject? So let us see the objectives. To develop the clear understanding of design philosophy amongst the students for the design of reinforced concrete structures using working stress method and limit state method. So the first objective is for you the introduction of two methods of design. So for RCC we have two methods of design, that is working stress method and limit state method. So we will see in detail what are these methods. The next objective is to study the various clauses of IS 456-2000 and its significance in the RCC design. So the second objective is you should know all the clauses in the Indian Standard Code, that is IS 456-2000. So similarly, you have seen there is a code for steel design. So in the same way, we have the code for RCC design as well. So you should be very thorough with the clauses which are mentioned. So it is like a guide for us. Whatever we are going to design, this acts as a guideline for the design purpose. So I request all the students to please carry a soft copy of this code. You can download it, or I can upload it on the Moodle for you. So please carry that copy, and then we can simultaneously refer the IS code and solve the problems. And one more thing, in the exam, the IS 456-2000 is allowed. The next objective is to apply the concepts of limit state method in the analysis and design of beams, slabs, and columns. So basically, you're going to study two methods, working stress method and limit state method, and you're going to apply that method in the design of the structural elements. What are the structural elements? Beam, slab, columns, these are called as structural elements. So we are going to basically design a complete building, the components of a building, beams, slabs, and columns. Next objective is to study the concept of serviceability and durability for the deflection and crack width calculation in RCC structures. So the next objective is we have to study how to find out the crack width and the deflection in the RCC structure. So basically there are two types of limit states. One is limit state of collapse and the other is limit state of serviceability. So in limit state of serviceability, these things come. That is, check for deflection, check for crack, and check for vibration. So the next objective is to study the concept of reinforced concrete footing design subjected to axial load and moment. So basically we are going to design the footing also. That is for axially loaded footing and also footing with carrying moment. And the next objective is to develop the concept of design using ready charts and curves for columns subjected to axial load and moments. So for the design of column, we are also going to use ready-made charts which are available in SP16. So with the help of that, we are going to design the columns. So the last objective deals with the design of columns. So I hope the objectives are clear with everyone. So let us move to the next slide. That is course outcomes. So what do you understand by course outcomes? So course outcomes means after studying the subject, what you should know or what you should be able to teach or understand. So the outcomes of the subjects are, first outcome is after learning the subject, you should be able to understand the pros and cons of WSM and LSM. So basically you should understand the difference between both the methods, what are the merits and demerits of each method. So that we are going to see in detail once the presentation starts. The next outcome is to understand the various clauses specified in IS 456-2000 for designing structural members with safety and economy. So again, we are going to use IS 456-2000. So you have to understand the various clauses in IS 456. So you have to be well versed with this code. The third outcome is to carry out the analysis and design of various elements of reinforced concrete structures, such as beam, slab, column, footing using the concept of limit state method. So basically, first you are going to study the working stress method, and then we are going to start with the limit state method. So you should be able to analyze, design the various elements. What are the various elements in a building? It is beam, slab, column, and footing. So you should be able to first analyze and then design all these elements with the help of limit state method. So that is one of the outcomes. And the last outcome is to understand the use of ready-made design curves from special publication of Bureau of Indian Standards. So again, this, as I have already told you, it deals with the design of columns. So in limit state method, while designing columns, we are going to make use of these curves which are given in SP16 and design the column. So basically you should be able, after learning this subject, you should be able to design a building. Okay. So let us move ahead. So now what are the recommended books? Okay, so in the syllabus copy, you can see a lot of books, but I have just shortlisted the books which are most relevant. So the first option which I will suggest is to go for RCC Designs by Dr. B.C. Punmiya, Ashok Jain and Dr. Arun Jain. Okay, so this book consists of both the methods, the working stress method as well as the limit state method. So it's a huge book. So if you can have this book, so there is no need to have any other book because it contains everything. It contains design of water tanks, design of chimneys, everything. So it contains basically both the methods, the working stress method and the limit state method. I would recommend if you have this book, then that is more than enough for you. And the second book is RCC Theory and Design by MG Shah and CM Kale. So this is again a very short book and very easy to understand. So this book is very good for WSM. It also contains limit state method, but I would suggest when you're dealing with WSM, you can refer this book. So it's very systematically and very easily given. You can understand this. So RCC Theory and Design, I would suggest you can use it for WSM. And then the third is Limit State Design of Reinforced Concrete by Dr. again B.C. Punmiya and Ashok Jain and Arun Jain. So this book deals with the complete limit state method of design. So in this book, you will not find any working stress method. So if you are if you are studying limit state method, then this is the best book for limit state method. And then comes the illustrated reinforced concrete design by V.L. Shah and Dr. S.R. Karve. So again, this is the textbook for limit state method. So the limit state method for Punmia, it's a very huge book. So again, the shorter version, you can find it in illustrated reinforced concrete design by Shah and Karve. And then finally, I would also recommend reinforced cement concrete design by Neelam Sharma. So again, this is a very good book for LSM. As far as numericals are concerned, there are quite good numericals solved in this textbook. So you can refer this for numericals. And for theory, you can always bank on BC Kunmia. So I hope you make a note of this. You understood what are the books. And obviously, we will also provide the necessary notes on Moodle account. So you can also refer that. So going on to the next slide. So before starting any subject, you should know what are the prerequisites of that subject. That means to understand or to learn that subject, what you should know or what are the basic knowledge you should have. So since this is the design subject, so before designing, what do? We analyze the structure. First, we analyze the structure and then only we design the structure. So you should be very good in analysis that you have already done in your previous semesters, that is structural analysis 1 and structural analysis 2. So before that, you should also know the strength of materials, that is mechanics. So if I want to add, I can add many things, but as far as your engineering syllabus course is concerned, so I have mentioned these topics. So strength of materials, it should be good. And then again, building design and drawing. So this is a very important subject which most of the students, they neglect. They don't actually take it very seriously. But this is the most important subject when you where you try to understand the drawings of the buildings and various components. You should be able to understand the plan, elevation section, because whenever you go on site, the first thing which you are going to do is you are going to read the drawings. So most students, they fail to read the drawings. They don't understand how the drawings are. So I would tell that the building design and drawing subject is very important. You should be able to understand and read the drawings. Again, for designing purpose also, you should understand the architectural drawings as well as structural drawings. And then obviously I told you structural analysis, by default you should be very good at it. And finally, not the least, basic mathematics you should also know to solve the problems. So these are the various prerequisites for this subject, and the conceptual and the theory part we will start. So with the help of these, you can easily master this subject. So basically, design subject is comparatively easy as compared to the analysis subject. So basically, you have to follow the design procedure and steps and refer the IS code. So I hope the prerequisites are clear to you. If at all, if it is not, then you can just revise with these topics. So going on to the next slide. So now we will see what is the syllabus of the subject. So we have seen the various things, what are the objectives, what are the outcomes of the subject, which are the books to refer, prerequisites, everything. So now let us see what is exactly in the subject which we are going to study in this semester. So the first thing is the first module. So I've just listed out the modules. So the first module is working stress method. So in this module, you're going to study the basics of the method. What exactly is the method? What are the merits and demerits of the method? And then you're going to solve the problems for beams, that is singly reinforced beams, doubly reinforced beams, and columns. And then again, the next module is limit state method. So you can say that only 20% of the syllabus consists of working stress method, and the rest is limit state method. So the limit state method, then the third module is limit state of collapse. So as I've already mentioned, limit state is divided into two parts, that is limit state of collapse and limit state of flexure. So in limit state of collapse, you have flexure, shear, bond, and torsion. Sorry, limit state of serviceability. So this we are going to see in design. So when I say flexure, it means bending. So in this, we are going to solve the problems for singly reinforced beams, doubly reinforced beam, design for shear, bond, and torsion is the conceptual part. And then in the fourth module, we will see the design of slabs using limit state method. And then in the fifth module, we will see limit state of collapse compression. So what do you mean by compression? compression member is a column. So in the 5th module, we are going to learn how to design a column. And the final module consists of design of foundation. So basically you're going to design a whole building in this subject. So I hope the basic syllabus modules are clear to everyone. So now we can just move to the next slide. So now we are going to actually start with the module 1, that is working stress method. So in this, what we are going to see, so I've just briefly outlined the topics which we are going to cover today. The first is the concept of reinforced concrete. So what do you understand by reinforced concrete? And then the material properties, and then the permissible stresses, and then different methods of design. And then we will see the comparison of working stress method and limit state method, and then the concept of balanced, under reinforced and over reinforced sections. And then the last part is analysis and design of reinforced concrete beam. Okay, so let us start with the first module, that is working stress method, concept of reinforced concrete. So what do you understand by reinforced concrete? So reinforced concrete is nothing but it's a composite material consisting of steel reinforcing bar embedded in concrete. So you have you already know, I think students who are from diploma, they already know what is reinforced concrete. So basically concrete is reinforced with steel. So it is called as reinforced concrete. So we know that the basic quality of concrete is compression. So I think I would request the student to please mute themselves. I can hear some sound. Those who have just entered the session, please mute themselves. Thank you. Okay, so we know that concrete has high compressive strength, but it has very low tensile strength. So that is the reason there is a necessity of adding steel to concrete to make it a versatile material for building construction. So then steel bars can resist high tensile stresses, but will buckle when subjected to comparatively low compressive stress. So we know the advantages of both the materials. Steel is very good in tension and concrete is very good in compression. So that is the reason we have combined both the materials for the concept of reinforced concrete. So moving on to the next slide. Yes. So steel bars are used in the zones within a concrete member which will be subjected to tensile stresses. So basically whatever the tension is in the member, it will be taken, it is assumed that it will be taken by steel, and whatever is the compression in the member will be taken by concrete. I hope this basic concept is clear to everyone before actually starting with the design. And then reinforced concrete is an economical structure material which is both strong in compression and tension. So that is the reason we have combined both these methods. So the material which we are getting is economical as well as it is strong in compression as well as in tension. Then concrete provides corrosion protection and fire resistance to the steel bar. So also the concrete provides fire resistance and corrosion protection to the steel bars. Yes, moving on to the next slide. What are the material properties of concrete? So the most important property is the compressive strength. We know that the most important property of concrete is the compressive strength. So the strength may vary due to operations such as transportation, compaction, and curing. So compressive strength is determined by conducting compressive test on concrete specimens after 28 days of casting. So basically, we know that the compressive strength of concrete is determined on the basis of 28 days of casting. So there are two types of specimen generally we consider. There is 150 mm cubes. Okay, so basically in India what we use is we generally use cubes, but in the US you can see that they also use cylinder. So now, so the dimensions of the cube we use is 150 mm by 150 mm. So now for your information, I would like to say that the strength of cube and cylinder, can anyone just type in the chat box the strength of cube or cylinder which will be greater, and then I will explain it further. So moving on to the next slide. Okay, so let us understand what do you mean by characteristic strength of concrete, which is denoted as FCK. So it's a very important important definition which you should know. So because we are going to deal with the characteristic strength of concrete, so you should understand what do you mean by characteristic strength. So characteristic compressive strength of concrete is defined as that value of the material strength below which not more than 5% of the test results are expected to fall. So by reading this statement, how many of you understood the definition of FCK? You can just type in the chat box. So in simple terms, if just let me see how many of you have typed in the chat box. Just give me a moment. Okay, so Uzair Kazi is saying cylinder. So the strength of cylinder is less or more. Okay, you have just. My question was whose strength is more? Okay. Okay, so Anis Patka is saying cube will have more strength because it is purely in compression. Okay, what about cylinder then? Rida is saying cylinder has more strength. Okay, so we have a very good discussion here. Yes, so the answer to that is, okay, I'll just go to the previous slide. So the answer to that is the strength of the cube will be more than the strength of the cylinder. Okay, so because when you consider the cube, the dimensions of the cube, you know, it is 150 mm by 150 mm by 150 mm. So we can see that as the size or the dimensions of the cube is increased from 150 to 450 mm, its strength gets reduced. Okay, so that is the reason we consider 150 mm by 150 mm size cubes to determine the compressive strength. Okay, so this phenomena is called as a size effect. So whenever somebody asks you why the strength is more, so you can say that it is due to the size effect that the cube has more strength than the cylinder. So I hope this is clear to everyone. So now let us move to the next slide. Okay, so characteristic strength of concrete. So what do you mean by characteristic strength of concrete? So characteristic compressive strength is defined as that value of material strength below which not more than 5% of the test results are expected to fall. So this means that if you have 100 cubes, 5 of those cubes should not have value less than the value for which you are going to design. That means if you have 100 cubes, 95 from those 100 cubes should have value greater than the FCK. I hope this is clear to everyone. 95 of the cubes should have value greater than the FCK for which we are designing. So here you can see in the graph, you can see if this is the mean strength. So 5% of the results we are not considering, and this is FCK. Okay, so the X axis represents the strength and the Y axis represents the number of tests or the number of cubes, or you can also call it as the frequency. Okay, so in simple terms, in simple sentence, if you want to understand what is FCK is, if there are 100 cubes, 95 of those cubes should have value greater than the FCK. So I hope this is clear to everyone. So let us move to the next slide. What do you mean by characteristic load? So now it is defined as that value of the load which has 95% probability of not being exceeded during the life of the structure. So now I think this is very simple to understand. So the definition itself, you can understand that 95%, it has 95% probability that it will not exceed during the life of the structure. So that is known as characteristic load. So now let us move to the next. Yes, so this is very important in working stress method, the permissible stresses. Okay, so permissible stresses are given by the ultimate stress upon the factor of safety. So whenever we are going to design in the working stress method, we would be required the permissible stresses of concrete as well as steel. So the permissible stress are given by ultimate stress upon factor of safety. So this is yield stress. So yield or ultimate stress I have written. So When do we say that it is yield stress? When we talk about steel, we say that it is called as yield stress. And when we talk about concrete, we say that it is ultimate stress. So I hope this is clear. I have mentioned. So if you want to find out the permissible stress in concrete, so that the ratio will be ultimate stress upon the factor of safety. Now the next thing is, what is the factor of safety which we are going to consider in working stress method? So as per IS 456-2000, the factor of safety for concrete is 3 and the factor of safety for steel is 1.78. So this is very important. So you have to remember this factor of safety. So you don't need to remember all the permissible values of the concrete. Just you can remember the factor of safety and you can find out the permissible stresses of either concrete or steel. So you have to remember this. This is very important. The factor of safety for concrete is 3 and the factor of safety for steel is 1.78. So now I would like to ask one question. Can anyone tell me why the factor of safety for concrete is more than the factor of safety for steel? So you can write that in the chat box and then we will discuss about it. So finally, we are going to start with the various methods of design of RCC structures. Okay, so I think we have only 2 minutes remaining in this session. So I would request all the students, once this session ends, please log in with the same ID and same passcode for the next session. Okay. Yes, we will come to that stress strain diagram when we talk about the various methods. So one has given it fails giving prior warning. Okay. So my question was why the factor of safety for concrete is more than the factor of safety for steel. Okay, so Rida is saying concrete is more brittle, steel is ductile. Is that the reason the factor of safety for concrete is more than factor of safety for steel? Okay, percentage air void in steel is less. Okay, any more answers? Mehfooz is saying concrete is exposed to atmosphere. Okay. So all of you are partly correct if I would say. Steel gives warning before failure as it is ductile. We know that it's a ductile material and it will give warning. So that is different. My question is different. Okay, so I think some of you have answered, so it is partly correct. So the reason for that is the reason that the factor of safety for concrete is more than the factor of safety for steel is because concrete itself is a very complex material and the study of which is very difficult as compared to steel. Steel is prefabricated, it is made in industries. So when steel is prefabricated, everything is decided prior and everything is calibrated accordingly. We get the results, so the testing is done, so we get the results very accurately. So that is the main reason the factor of safety for concrete is more than the factor of safety for steel, because steel is prefabricated, we know everything about it. As far as concrete is concerned, it is a very complex material. So that is the reason we have considered the factor of safety more for concrete as compared to steel.